Okay, I was asked to show how to solve this problem. And if you remember, what's happening is the boy here is going to kick this soccer ball. And it's supposed to just barely clear this fence. And what we're looking for is the minimum speed for this thing to clear. And there's a couple of misunderstandings that students use. First thing was this little equation over here in red, where the idea was that, well, the initial angle theta 0, which isn't known, was equal to somehow the inverse tangent of this 3 to 6 triangle. But remember, 3 and 6 is position. Position is related to velocity only through the derivatives and integrals. There's no reason to even think that the angle that you're kicking this ball has anything to do with this 3 and 6. So this red equation is totally bogus. So what you do is you come in and you say, well, it's 2 degrees of freedom. I know 2 accelerations. G is downward, 0 horizontally. So that you don't need a free body. Because the accelerations are constant, and because this is a time spanner, you're going to want to integrate. So you're going to use the handy-dandy formulas, which are here, because the acceleration is constant, and I'm integrating. And then you just plug and chug. So you come in and say, well, I'm going to apply the positions because I know where the ball is when I first kick it, and I know where it clears the fence. So you put in numbers for this, and so you have 6, this equation up here at the top. 6 is equal to the initial velocity in the horizontal, that's v0 cosine theta, times t, and then you got your 3 and v0 sine theta t minus 1/2 gt squared. Now, if you count the unknowns, they're circled in red. You got the initial speed, you got the initial angle, and you have the time. So you have 3 unknowns and only 2 equations. You can't solve that the way it is, so you have to look for more equations. Number 1, you look for other free body diagrams. It's crazy, there are no free body diagrams for this problem. Number 2, you have to reread the problem, right? And so what the author wants is he wants the minimum speed, right? It says it right here. He wants the minimum speed, for this ball. And so the equation is or the problem is that you want to minimize speed. Now, I'm sure that you've done calculus problems where you're finding minimums. The way you find minimums is you write the thing that you want to find the minimum of. So, for example, in the math problem, it was always y equals something x, y equals x squared minus 3 or whatever. So you said, okay, and I want minimum y. So you say y equals, so that's what I want. I want minimum v0. So what I'm going to do is find v0, and there should be variables left over. And then I'm going to take a derivative, set it equal to 0. So that's how you solve this. And now what I'm going to do is show you how to do this. And then here, I'm trying to do it by hand. I'm going to solve for t, take t, stick it in wherever t is, and you massage, massage, massage. But I'm going to show you how to do it with Mathematica. I'm going to pause and get the Mathematica up and running. Okay, so here I've pulled up Mathematica. The first thing I do is I quit. And then I've just typed these 2 equations in. I believe I've not made a mistake. But those are my 2 equations. Now I'm going to slide this over so it's a little more easy to see. And what I'm going to do is execute this. So here are my equations, and the next thing I want to do is I want to solve this. I have 2 equations, so I can choose 2 variables that I want to get rid of. And so what I'm looking to do is I would like to have an equation that says VO equals something. And that way I can take a derivative. So I'm going to solve this equation. And the 2 things, I want VO so that I can have VO is. And then take your pick. What do you want to get rid of? Oh, I think I'll get rid of the T. It could be theta here. But anyway, so we'll take a look at that. And yeah, not too bad, right? So I have 2 answers because it's quadratic, right? So you're expecting 2 answers. The first one, if you notice here, let me zoom in a little bit. 150, we'll see if that works. Okay, expand the window, boom, and boom. Okay, so that's not too bad. The other thing you can do is, I don't think it'll help too much, but you can simplify. So you can ask Mathematica to simplify this thing for us. And I don't know if that's any easier. But anyway, look at the two answers. One of them has a negative time right here. See that negative out front? This one's a positive time. Clearly, I don't want the negative time. So here's my VO right here. And so I'm going to copy that. And I'm going to paste it in down here. So I'm going to say, okay, VO is 1 equals sign. I'm not going to try and solve this for anything yet. And I just paste it in, right? So here's my VO. Now, what I want to do is I want to minimize this. So how do you minimize something, right? So execute that. I'm going to give this a VO. How do you minimize this? Well, what you do is you take the derivative. The way you do a derivative in Mathematica is you say capital D. Yeah, you'd think that they would make you type out derivative. But anyway, capital D. What do you want the derivative of? I want VO, right? What do you want to take the derivative with respect to? Like in math, it was always y is some, x cubed or whatever. And so you always took the derivative of y with respect to the variable, with respect to x. In this case, I don't have x. The variable is th. So you want the derivative with respect to th, right? So let's just print it out and see what it looks like. Oh, that one's not too pretty looking. But let's see if I can simplify it. Simplify. And boom. Whoops, I forgot an extra simplify. Yep, I need a bracket there. All right. So that one's not too bad now, right? So it simplifies down a little bit. What do you want to do once you take a derivative? Oh, you know what? I want to set that derivative equal to 0. This is an equation. I'm going to try and solve for theta. So I'm 2 equal signs. Equals equals 0. So there's my equation. What do you want to do with this equation? I want to solve it, right? So what I'm going to do is I'm going to go up here and I'm going to say, okay, let's call this my derivative equation. So I have a name, derivative equation. So, I'll just show you what happens. The reason I named it that is because I can say DEQ and I get exactly the thing back. All right, so what do you want to do with this equation? Oh, I want to solve it. Solve DEQ. What do you want to solve for? Well, the only thing that's in there is TH. All right, so solve it for TH. Okay, so here we go. And it says inverse function, blah, blah, blah. Okay, it's just telling me how it solved it. You know what? I'd like to see that as a number. So, you know what? Give it to me as an N. The other thing you can do is anytime you put a decimal point on any of your numbers, it's going to come back and automatically default to numbers. But here I want it to be numbers. Now, the TH is in radians, if I'm not mistaken. I never said degree. All right, so there's 4 answers on this. I don't know why there's 4, but there are. Okay, so let's take a look at the angles. Do you want negative angles? No, absolutely not. So it's either this one or it's this one, right? So I'm going to try them both. I don't know which one. Now, the mathematics people would say, oh, one of these is a minimum, one's a maximum. You can take a second derivative, blah, blah, blah. I don't want to do that. That's too hard. So here's what I'm going to do. I'm going to go back in here and I'm going to say, what was the VO, right? So it was right here. I'll say, okay, just to confirm, I've got VO. There's my VO. What I want to do is I want to try and put in these 2 angles, and I want to see which one is the minimum, right? So I'm going to grab this guy right here. I'm just going to copy and paste. You don't need the curly brace because there's really only the one. And I'm going to put it in down here, and I'm going to say, I want you to temporarily substitute that in, and this is how you do a temporary substitution. You type VO divide and period, and then we'll paste it in, and we'll see what the number is, 9.75. Okay, let's also do that for the second number, this guy right here. Like I said, you don't really need that curly brace, whatever you happen to get, and execute that one. Oh, the second guy is completely imaginary. That's obviously not the right one. So this is the one you want. So what's the minimum velocity? 9.75. And that's it. All right. So Oh, by the way, if you wanted to, if you forget how to do temporary substitutions, you could do this. You could go in there and say, okay, let's try this guy. I want TH to be equal to that at all times. So you say, boom, instead of the arrow, the way you get the arrow, by the way, is you say minus greater than. As soon as you hit any other key, it'll turn into an arrow for you. So you say TH is 1.01. And then you can say, what is VO? And it'll take that guy and put it in there for you. The other thing that you can do is if you wanted to test this guy, right, this is kind of redundant, really. You could do the same thing. You say, well, I wonder what VO is when I set this, TH equal to that angle. You execute that and say, well, what's the VO now? Is imaginary. The same thing that we had before. So anyway, there's your VOs, 9.75. That's the solution. Oh, by the way, if you wanted to, let's go back to the very beginning. Here, where I solved these equations, and I solved them for VO and T, if you wanted to, you could also come down here. Let's just copy and paste them in. Solve the original set of equations for VO and theta, TH instead of T. And let's see, whoops, okay, I need to do a quit. Let me quit. I'll quit. I'm going to go get these equations. Here we go. Copy, bang, bring it down here. Here we go, slip it in here. All right, bang, there's my equations. That's because, see, I already said what TH was and kind of freaked out. Okay, and then solve for that guy. So what you have to do is you say, would you rather take a derivative of this stuff or this stuff? You should get exactly the same answer. But this one down here looks a lot uglier. Mainly because when you're solving for the angle, you got multiple, infinite number of solutions, right? Which is trying to do here. If you really want to keep beating your head against this thing, you can go in there and say, okay, I want to solve this thing, and I want C1 to equal 0. And simplify that. So here we go. And again, which one do you want? Well, you're going to have, let's see, this one probably is the one that's positive, right? So we're going to start with this guy. And we'll come down here and say VO. I mean, this is ridiculous. This is way too hard. But anyway, so we'll paste that in. And now you have VO in terms of time rather than TH, right? So you hit enter, and what do you want to do? You want to minimize this, right? So you want to say, I want to take the derivative of VO with respect to time this time, because that's the variable that's in there. And you get this ugly looking stuff. Let's see if we can simplify it. Let's see. Bang. Boom. That's not too bad. What do you want to do with this? You want to set it equal to 0. And what do you want to do with that? I want to solve that. So solve that equation for T. So there's my T, and let's see, this one's clearly imaginary, so forget that one. This one here is imaginary, this one here is negative, and this one's positive. So what I'm going to do is I'm going to take that, and I'm going to plug it into the VO, and plug it in. T is bang. There we go. And ask it as a number. So I'll show you that you just change any of these to a decimal, and it'll get you as a decimal. What did we get before? 9.75. Right there, 9.75. So it doesn't matter which one of these you solve for, but in my opinion, the first one was probably the easier one. How did I know that? Yeah, I just did them both. You certainly don't want to do that, both of them, by hand. You want to find one that works for you. Anyway, that's it. So I'll post this.